In today's world, AI is everywhere. We use it to write articles, get movie recommendations, and even make investment decisions. AI brings incredible efficiency, but at the same time, a quiet yet massive trust crisis is unfolding. Why is that? Because the more decisions we hand over to AI, the more trust we're outsourcing. And the problem is that trust isn't always reliable. Take data poisoning attacks, for example. AI learns from the data it's fed garbage in, garbage out. If someone sneaks malicious information into its training data, the entire model gets corrupted. Imagine a self-driving car that learns the wrong traffic signs. It could make catastrophic decisions on real roads. Or AI trading bots losing millions of dollars in seconds because they were fed faulty market data. This isn't sci-fi, it has already happened. Then, there's the risk of AI agents spinning out of control. On blockchains, these agents were supposed to be the future executing trades, moving assets across chains, even managing portfolios for users. But if an agent hits a bug, or worse, gets hijacked, your funds could vanish instantly with no way to recover. One wrong move, and your money's gone. And of course, there's the rise of deepfakes. What used to be a lab experiment is now one of the most dangerous weapons online. Fake celebrity videos, fabricated political speeches, or even AI-generated clones of ordinary people, spreading faster than ever. It's getting harder to know. Is this video real? Was this photo taken or generated? When truth itself becomes uncertain, trust in information collapses. Finally, there's the black box problem. AI often gives an answer, but we have no clue how it got there. In areas like healthcare, justice, or finance, this lack of transparency is a huge risk. When lives, court rulings, or even market stability are on the line, not knowing why AI made a decision is unacceptable. See the pattern? Whether it's poisoned data, rogue agents, deepfakes, or black box reasoning, it all points to one core issue. In the AI era, we're losing the ability to verify. Think about it. Data is the raw material of our world. If everything is data, then whoever can verify its authenticity holds the power. And right now, AI is both the biggest producer and consumer of data. It shapes what we see, what we believe, and even influences money flows, public opinion, and geopolitics. So here's the big question. Can AI itself be verified? Can we confirm its data is clean before it makes a critical move? Can we verify every calculation, every output, every action? If not, AI becomes a runaway black horse, powerful, but uncontrollable. If yes, then we can build a new trust system and make AI a truly reliable partner. And that is exactly what DeepSafe is here to solve. Just now, we talked about how the trust crisis in the AI era is accelerating. At this point, many people might ask, wait, don't we already have AI security solutions? Aren't there tons of AI security companies out there? Yes, it's true. In recent years, a wave of AI security technologies and solutions have emerged. But here's the catch. None of them truly solve the core problem of trust. Why? Let's take a closer look. Consider the centralized AI security model. In the traditional setup, you usually rely on a single big company to certify the safety of an AI model. They'll tell you, our AI has been tested and verified. It's safe to use. Sounds reassuring, right? But beneath the surface lie three fatal flaws. 1. The single point of failure. When you hand all your trust to one company, what happens if they get compromised? Whether it's a cyber attack or misconduct from the inside, the entire system could collapse overnight. Think of the 2008 financial crisis. Everyone trusted the AAA ratings from centralized agencies, until it triggered a catastrophic chain reaction. 2. No unified standards. Every company has its own definition of AI safety. Company A runs one type of test. Company B uses a completely different process. With no universal, interoperable standards, users are left wondering, which AI is actually safe? Whose evaluation can I really trust? 3. Sky-high costs. AI safety audits are extremely expensive. For big corporations, spending tens of millions on a security framework is feasible. But for startups or small teams, that cost is an impossible barrier. The result? AI security becomes a luxury good only the giants can afford it, while smaller players are left to operate naked, with no protection at all. So in the end, centralized AI security doesn't solve the issues of accessibility or trustworthiness. It's more like insurance for the few, not a safety belt for everyone. Now some might say, all right, if centralization is flawed, then decentralization must be the answer, right? And that brings us to the second topic, the limitations of existing decentralized approaches. Blockchain does introduce exciting new possibilities. Consensus mechanisms can ensure transparency. On-chain verification can prevent tampering. On paper, it sounds perfect. But once you bring it into real AI scenarios, the cracks start to show. First, the problem of efficiency. As we all know, traditional consensus mechanisms like POW or POS are great at validating simple transaction data. But AI workloads are a different beast entirely. A single inference on a large model can involve tens or even hundreds of billions of parameter calculations. Now imagine asking blockchain nodes to verify every single step of that process. It's practically impossible. That's why today's decentralized verification methods simply cannot keep up with the computational demands of AI security. Second, the lack of privacy protection. To verify an AI's outputs, you often have to expose its internal parameters or training data. But for AI companies, that's like running around completely naked. After all, a model is their crown jewel, their core intellectual property. If it leaks, the consequences aren't just financial losses. It could mean their entire IP gets stolen overnight. So most existing solutions are forced to make a trade-off. Either you verify correctness, or you protect privacy, but never both. Third, poor cross-chain support. In the real world, AI doesn't run on just one blockchain. Some data may live on Ethereum. Some computations may happen on Solana. The results may need to be anchored on Bitcoin. Yet most current decentralized AI security frameworks are confined to a single chain. They lack a unified cross-chain verification standard. It's like driving across multiple countries, only to be forced to retake your driver's license exam every time. Inefficient, frustrating, a terrible user experience. So, let's recap. Whether it's centralized AI security systems or the decentralized approaches we've seen so far, none of them solve the root problem. They either rely too heavily on single authorities, suffer from efficiency bottlenecks, sacrifice privacy, or fail to work across chains. Which leaves us with a big question. Is it possible to build a framework that avoids the single-point risks of centralization, while also overcoming the efficiency and scalability limits of decentralization? A framework where every AI input, computation, output, and action can be verified securely, transparently, and at scale. The answer is yes. And this is where we introduce the next chapter, DeepSafe's AI security revolution. Think of it as an AI security firewall. Every piece of data, every computation, every action, and every output generated by AI must pass through these layers of verification, ensuring safety and trustworthiness at every step. Let's break it down, layer by layer. Layer 1. AI data verification. Data provenance, never forged. As we all know, data is the fuel for AI. If the training data is corrupted, no matter how powerful the model is, it will generate flawed, even dangerous results. DeepSafe addresses this with two key technologies, Ring VRF and data provenance tracking. Using Ring VRF, we randomly select an anonymous audit committee. Their mission: to verify the source and authenticity of training data. Randomness ensures fairness, while anonymity ensures security. At the same time, every dataset is issued a birth certificate on the blockchain recording its origin, transformation, and whether it has ever been tampered with. If contaminated data is detected, DeepSafe automatically isolates it, just like an immune system separating viruses from healthy cells. For example, imagine a financial AI model is secretly trained on falsified market data. In traditional systems, this could go unnoticed until the model makes catastrophic trading decisions in the real world. But with DeepSafe, the polluted data would be intercepted before entering the model, killing the risk at its source. Layer 2. AI Computation Verification. Turning the black box transparent. Clean data is only the first step. How do we ensure the computation process itself is secure? Often, AI training and inference are like a black box. You see the input and the output, but what happens inside remains a mystery. DeepSafe solves this with two powerful tools, T and ZKP. TEE, Trusted Execution Environment, acts like a secure vault. All AI computations happen inside, shielded from interference or tampering. ZK, Zero Knowledge Proofs, allows the AI to prove its computations are correct without exposing model parameters or private data. And importantly, this verification is not handled by a single node. It's performed in parallel by multiple CRVA nodes, making it faster and more resilient against attacks. In short, AI is no longer a black box. Its computations can be verified without sacrificing confidentiality. Layer 3, AI Agent Behavior Verification, pre-authorized supervised fail-safe. With the rise of AI agents, we're seeing more AI systems directly execute on-chain actions, placing orders, transferring assets, even making investment decisions. But what if an AI agent goes rogue? The consequences could be disastrous. DeepSafe establishes a behavior monitoring and authorization system. Pre-authorization. All critical AI agent actions require approval from a CRVA committee, just like a plane needing clearance from air traffic control before takeoff. Real-time supervision. Every important step is monitored and validated in real time like surveillance cameras on a highway. Fail-safe mechanism. If suspicious activity is detected, DeepSafe immediately triggers a circuit breaker, halting the AI's actions even mid-operation. Example: if a trading bot suddenly attempts to transfer all assets to an unknown address, DeepSafe would instantly block the transaction, protecting user funds. Layer 4. AI Content Authenticity Verification. Truth identified, trust preserved. Finally, we address AI-generated content. AI is now capable of producing text, images, and videos that look increasingly real. But this creates a crisis. How do we distinguish truth from falsehood? DeepSafe introduces a content authenticity verification framework. Every piece of AI-generated content is stamped with a cryptographic fingerprint, like a unique seal of authenticity. If a piece of content is questioned, the CRVA network launches a collective verification process, using consensus to confirm its authenticity. A reputation system further reinforces this. AI models and creators gain reputation by consistently producing authentic content. Caught forging? Their reputation drops, or they're banned entirely. This means users no longer have to rely on gut feeling to judge truth from lies. They can rely on a transparent, trustworthy, and tamper-proof verification system. In summary, DeepSafe's 4-layer architecture secures every critical dimension of AI: clean data, trusted computation, controlled behavior, verified content. Together, they form a multi-layer firewall, systematically resolving the trust crisis of the AI era. And the big question is, with such a system in place, what breakthrough applications become possible? That's what we'll explore next: the powerful synergies between AI and DeepSafe. Let's start with the most straightforward use case: decentralized finance, DeFi. AI trading bots have already become one of the key players in DeFi. They can automatically place orders, perform arbitrage, and provide liquidity, all with an efficiency far beyond human traders. But here's the risk: if the data source is tampered with, or if the AI falls into hallucination, a user's funds could vanish within seconds. This is exactly where DeepSafe proves its value. With data verification, we ensure the market data that AI relies on is authentic and trustworthy. With computation verification, we guarantee the AI model's reasoning hasn't been tampered with by hackers. With behavior verification, we prevent AI from transferring assets without permission. With content verification, we make sure trading signals themselves aren't forged. In short, users no longer need to worry about rogue AI actions. DeepSafe oversees and verifies the entire pipeline, allowing AI to keep executing at high speed, but now with security and trust massively reinforced. Now, let's look at NFTs and digital content. Generative AI can now produce art, 3D models, or even entire virtual characters within minutes. But the big question is, how do we guarantee ownership and authenticity? DeepSafe provides a system of fingerprint certification for content. For example, when an AI-generated artwork is published on-chain, it automatically carries DeepSafe's verification signature. Collectors can clearly see which model it came from, whether it was modified, and the reputation of the creator behind it. This means NFTs are no longer just a JPG. They become verified digital assets with traceable origins and credibility. In the real world, DeepSafe's impact is even greater. Imagine a hospital using AI for medical diagnosis. Patient scans and medical data are fed into the model, and its output may directly determine the treatment plan. But if the AI model is attacked, even if a single data point is altered, the result could be a misdiagnosis, or worse, a threat to human life. DeepSafe's role here is to protect the model through T&ZKP, safeguarding privacy while ensuring correctness. Hospitals can trust AI without compromising confidentiality, and patients can be confident that diagnoses are verifiable and traceable. This way, we protect both medical privacy and safety. Now, let's zoom out to the industry as a whole. In the past, blockchain verification was limited. We verified whether transactions were real, whether addresses were valid, whether assets existed. But with the rise of AI, the scope of verification expands infinitely. Because AI doesn't just generate results, it executes actions and influences human decisions. DeepSafe effectively lays down a verification network at the foundation of the data economy. Any AI, any data source, if it wants to be trusted, must pass through this verification layer. This will gradually reshape the entire industry. Security will no longer be an optional feature, it will be the entry ticket. In DeFi, future exchanges and protocols won't just compete on liquidity and speed, they'll highlight verification as a core value. In NFTs and content, authenticity will become just as important as artistic creativity. In enterprises and scientific research, AI verification will emerge as a public utility, like electricity or the internet. DeepSafe is transforming verification from a patchwork feature into the underlying logic of the entire industry. Finally, let's talk about the future. With the rise of decentralized science, DeFi, more and more scientific data will be processed by AI. If this data can't be verified, the credibility of entire research results may collapse. DeepSafe's verification network ensures that every piece of scientific output comes with a complete chain of trust, blocking academic fraud before it happens. At the same time, the rise of AI agent DAOs means AI will gradually evolve from tools to autonomous entities. They will make decisions, execute tasks, and collaborate with other AIs. But without verification, AI DAOs would be like a swarm of unregulated black boxes, unpredictable and potentially chaotic. DeepSafe provides the trust protocol they need, so AI can be tracked, constrained, and audited. In other words, DeepSafe isn't just a temporary patch for today's problems. It is laying down the infrastructure of trust for the AI era. One day, when we look back, we may say, it was DeepSafe that transformed AI from a mysterious black box beast into a trusted partner.